I think somebody muted again. Just I'm trying to show like if you want some type of image, okay, how we are going to create. Okay, we can select here and we can make a. Sorry. Okay, I will show in the PPT. I missed it. So there is the application where we can develop our HMI. Okay, these are the different type of toolbars. So additionally, we can browse that points also from here. Okay, and so from view menu, we can enable or disable like these toolboxes. Okay, Object Explorer toolbox, and we can hide it. So when we launch a new display, so this will be starting with the display one here. Okay, where we are going to make up programs. Sorry, where we can create a display images. So normally, like if any diagram if he wants to draw, okay, we before that we need to understand like what is the customer Windows resolution. So based on that, we can develop this uh, uh, HMI size. We can take this HMI size. So normally this will be starting from like a pixel basis. So 0 to 02, it will keep on increasing here. Okay. So okay. So somewhere grid. Okay, so this is like a grid format. Okay, for while develop, this will be like our develop image developing area. So this will be adjusted based on the our customer requirement and what is the display resolution. Based on that, we can create it here. Okay, we can adjust it, and there are something. This is the property grid, like where we can like a size we can check it. Okay, pixel size. So when we are trying to create a new display, so this many options will be available. We are can create a new display or a new pop-up or like a shape sequences or dynamic shape. Okay. So when if you are selecting as a new display, okay, this will be like a standard operating display. The full screen default size is like a 1020 and 589. This is the resolution. The HMI will. Okay, when we select this display, but we can adjust it, okay, based on our requirement, and does not have a scroll bars when you called up in a station when this size. Okay, and saves with the file, and it will be saved with the file extension of when you create a new display, this will be saved with the file extension of .htm. So when you select up new pop-up, so the pop-up is like a secondary window display which will be used in this display. So this will be called here, and we can use as a, like a pop-up window. And this is called I don't know why I'm getting muted continuously. Okay, so it provides like a appears when user clicks an object to which it is attached. So it will be like any object if you click from the display. So this pop-up will be appear when we use this option, and it provides a way to control point parameters and similar to faceplate. It's a kind of faceplate, and the default size is like a 300 into 300. Okay, it saves file extension of .htm. And we have another option called the shape sequence. Okay, during operation time, like this will be the different type of save sequence. Okay, various condition. If we want to say display the various type of shapes like a color, we can use this. So shape sequence we can create this, and for one shape we can create a different types of colors or different types of variations, and this will be used in for it's kind of in operation like to show this for various condition. So this is called a shape sequence.
Sorry, you are muted again.
I am not sure what is happening. Okay, let me see whether we can find out who is meeting it. Don't know how I am getting muted. Okay, so these are all about like a shape a sequence, how to create like a shape sequence, and so dynamic shape. We have option like a dynamic shape. So this is alphanumeric or dynamic type. If we create this, it will be appearing like this. So by using one dynamic shape, we can display like a multiple values, SP, PV, or we can add some other values also to indicate. Okay, it can be inserted into standard display. So uses custom properties to link the plate pointer or parameters in the database, saves with the file length extension as a .sha. So display from template. So when we select the display from template, so it will be coming with some standard size or a standard operate template. So if you required, we can select this one. So to create like a creating objects, to create regular shapes, okay, like a rectangular or a circle or like a anything, we can use these objects. Okay, and by after selecting this, we can do rename the object based on its function, like a flow indication or a temperature indication, something. Okay, and while creating like a text object, we can use this, select this option, and we can write some text. Okay, to inform like any information for the operator. To create a hyperlink, so we are having this option. We can select and drag and drop. We can provide the name here, and in details window we can copy paste the website or the hyperlink name. To create a trend, okay, so we can select this trend here, and if we like select any where we want to plot, we can select in the HMI page, so the trend will be created. And by double click that, we can create add object, and we can select a period, or we can check the like we can modify the x-axis, y-axis ranges, or we can add the trend titles. In case of like a irregularly shaped, which not like a regular shape, by using this like a polygon option, we can develop it. So that's what I'm trying to develop some on like a pump, but somewhat I'm not getting properly. Okay, we can develop here by using this polygon icon. Yeah, and these are all like toolbars which is available. Uh, if you want to create a, like a new tools here, so we can go and customize, select a customize, and create a new name, like something like a grouping, something. This is a group icon. Okay, there will be created a new tools in your toolbox. So by going this customize option, like a which what and all uh, tool should be there, you can just drag and drop it here. So this is a kind of scripting which we can use it in the um, let me show you. So if you want to do some scripting, okay, you can create some tag, assign some value to here. Okay, and can what is the name for this? It's alpha numeric. You can create. Okay, so you want to by getting this value, you want to write some script. So go to edit script, and here you will be having option for the test tag, and you can write a script. So the script when it will execute like a there's some various conditions are there. So you can select any condition when it is active or like a on change. So on change will give you like a whenever this particular value changes. Okay, a test attack, it will execute the script. Okay, and on click, if you click or on something context menu on double click. Okay, on key press, on key up. So something like a various options are there. You can select when you want to run, like run this script. So now normally you can write like a when this script is above this value, we can develop, generate a alarm or something, or below this value, we can generate an alarm, or you can blink, or you can change the color of the value. So all those things by using this on change, we can write a script here. So this is the script, like the script, what the script is saying, like this is the tag name, and when the tag name, like if it has some unacknowledged alarm exist, and then they are like creating some, they are trying to do some action by using the script. Okay, so we have like a script selecting languages. Check it. So this is like the language script what we are using. Like so before like 500 days we are supporting VB script, but after 500 releases, we are recommending to write a script in the J script. Okay, and so this option will like a auto save while developing any HMI. If you forgot to save also, this will save automatically every 5 minutes once. Okay, so this is the grid value. When we select a pick that grid, so how much of grid should be there for per pixel? Okay, what is the grid color? So this is the path which we can add if you are creating any uh, if you are inserting any shapes into the like a display, then you have to add this path. So so then only that will work. We can include in the shapes here. Sorry, if you create any HMI and saving in different location, you have to include all the paths here. So that's why when you call a HMI, then our station will search all the HMIs in this path. Okay, so that's all. There is something replace. Okay, so we have already developed a HMI. Okay, we have made some HMIs. Okay, now we need to replace so customer is requesting to replace the particular shape to different. So by using this option, we can select a HMI and we can replace the shapes. Okay, we can add old shape. Okay, and what to be replaced? Old shape name and new shape, and you want to resize or something, and we can replace it here if a customer wants to change some shape. Okay, and the display performance analysis. So once we develop our HMI, okay, we can by using this option we can like select as display performance analysis can be done. Okay, these all are the recommended suggested limit for each and everything. On-demand data transfer should be 200, but we have not used anything. So data transfer that allows fast update like a 200. Right now we have used 31. So like we can see the limitation here, and we can create a HMI based on the limitation. We can display, we can change a report. So we can select a report here. Okay, select all, and we can click OK. So it will generate a report. Okay, we can save this. So this is like if you open any display, we can double click or we can right click and select properties. We can go to the display properties. We can create a name. So this will be like a saved in set display. Somewhere it will request for save. Will save in the .htm format. So now the display name will be changed, and appearance we can change the color. Okay, background will be changed, and this is like a cascade style sheet. Okay, I will come to you like a after some PPT. So there are like a various options available in the displays. Okay, so here only we will decide the pixel size. There is appearance. So here we will be deciding what is our required pixel screen resolution. So based on that, we can configure here. Just I want to try to show create this kind of image, but I'm not able to do. Okay, like a small image we can create by using these tools, and we can by creating this image, and by using this trim tool we can do create this kind of image which looks like a pump. So it's like a SCADA for any. If you double click after the creating this image, it will give this kind of properties page. We can assign a tag for that. Okay. So this is like a normal HMI builder. So next we will move to like a solution pack. So HMI solution pack will be like a which Honeywell is developed like a standard HMI displays, which will be helping for engineers who doing engineering activities at site or any. Okay, so this has all no need to create anything, any shapes from the scratch. What we did here. Okay, it is like a creating from the scratch, but already Honeywell has created like what are the tools will be used in the plant. So all the shapes will be developed, and we have kept in this folder that is called HMI solution pack. Okay, let me show you in the system what are all available. So these are some of the images which I have selected from the HMI solution pack standard displays. So this is the CDA shape overviews. So these are the shapes which will be used in the CDA, and the SCADA shape overviews for SCADA communication purpose. So by default, it will be installed in the abstract folder. Okay, but in this server, it is not installed. So I copy pasted here HMI solution pack. Okay, here we'll be having shapes. So these shapes for a CDA communication. So for if you are collecting any CDA data, you can use these shapes. So we can see like a three-way valve CDA, analog output to bars, browser, blowers, breakers. So like we have many number of shapes, and which is having like a different types, different configuration. So controller which is having like a regulatory control, we have this many options. Okay, we can control valve for CDA. We have this many options. If you do anything like drag and drop here, we'll see what is. So this is the control valve. We can assign a tag here, and so based on our requirement, we can do our configuration. Hmm. So solution pack. This for CDA objects. Similar way we have for a SCADA, like a SCADA objects. We have many shapes are there, and like a foundation field bus, okay, and like a HG, HVM, PMD, SCADA simulation environment, and in case of static. Okay, this all shapes are available. Just we need to like drag and drop, and we can start our configuration. No need to create anything from the scratch. So graphical sorry. Sorry. So the HMI solution pack goals are like a standardize the consistency, common look and feel for all chips, effective plant operation, flexibility in use, like a library, common compatibility, easy to share, low maintenance cost, and a detailed shape documentation. So graphical display should be effective and not complex or cluttered. So promotes visibility and consistency in a graphical display. The techniques for hiding and showing detailed information such as tag names and engineering units. Okay, and so this is like a consistent of a color usage. Here the number of colors is minimum and consistently applied across display hierarchy levels. Red and yellow used only for alarms. Avoid color combinations that are susceptible to the color blindness. So color is a redundant visual coding on information. It's a purposeful use for like animation and or flashing the text. Numeric formats are consist with the appropriate level of operation of friction of to enable the quick reading and quick reading. In easy navigation, it's like a use of standard display hierarchies. Navigation to primary display is possible without the use of the display menu directory. Depict equipment without excessive details to facilities. Can I muted? The main feature like a deliver maximum functionality with a high performance, consistent operation philosophy, easy display implementation, support of multiple level display content, and easy cloning and adoption of for objects. The pop-up and faceplate support, shortcut menu support, flexible color and text configuration. So this is the HMI solution pack installed to path. So as we saw earlier, like everything will be available here. Okay, HMI solution pack example displays also here, but in our case we don't have HMI solution. Example displays here. Okay, HMI solution. So these are example displays available. Example displays also available. Its shapes are available for all types: CDE, SCADA, static. So each type has a multiple options based on the shape, alignment, and the data displayed, etc. Okay, this is the naming convention. Okay, so here it will CDA is telling like it's for used which application CDE, SCADA. Okay, and this is this name is talking about like a function like a regulator control valve. Okay, and it's a kind of ISA. There are which is standard it is developed. There are, I think there is a two standards. One is ISA. The orientation is H or horizontal. Okay, horizontal or vertical, and alarm is enabled or not. Okay, that's what uh, the PSO metric is a function. Okay, and the number is like a index number. So this is like a revision number. So this PSO means like a set point, a PV set point, and output mode, and I think alarm, and something like I will be talking about alarm. So these are the information. So based on that, this naming convention is there. So in this folder, we have a saved documentation also. We can select the documentation and we can see how it is functioning, each and every saved displays. Okay, this is like a CDA control walls. Okay, which is available here. Control wall it is drag and drop here. So you can see like a many shapes here, and a graphic script holder like a GSH. So a script holder are used to centralize the script in one location, which improves like a maintainability as well as a performance. In our 5-axis series, all scripts are stored in the single GSH, which means like a SP underscore GSH. It's like a graphics script holder. Yeah, and the script folder should be present in the abstract or scripts folder. Similarly, we can add three additional script holders to your template to display as shown in the below, like a common GSH and C menu the GSH. Okay, and a trend SUH CSH. So this graphic script holder will handles all mouse events in the HMI. So provide support for navigation as well as the support for shape. C menu GSH contains a subroutine for a shortcut menu option. The shapes contains all subroutines for shortcut menu selection, such as alarm, acknowledgement, detail, okay, and group, trend group and a trend group column added to trend functionality, view trend configuration. So trend SUP GSH will show all points and parameters in the current trend group. It contains a table which will show all points and parameters in the current trend group. Okay. So next we will move to the cascading. I'm just reconnecting that server. This I have sample, I have developed one sample. Okay, so here we are seeing like this is the line size is thin. Then this is the next two, and this is the third level size. This is the with a different color. Okay, so this all will be like a we have generating manually. We open this control filter. Open. Okay. So normally what we will do, like if you want to any style change, so we can go here and we can adjust size. Okay. So the color indication we can change, and the line size. Okay, where is the size here with line width? Okay, we can based on our requirement we will adjust it here. But this all changes like a size, color, and in case of any alarm indication. So like all animations or like a configuration will be saved in the cascade style sheet. Okay, so how first which is available here, CSS. Okay, and SP. This is like SP CSS file. Go and edit. So here we are importing like a many functions, many CSS functions. So we will in each CSS function, this is returned like a different kind of size values, and what should be the color. Okay, and what it should be the blink or something. Okay, this all files will be having uh, this kind of information. Uh, we can take any one example like it's a common. So first is common file. So if you go and select here common, there is a common file will be there. You can edit. So here everything is written to like a what is the roundness, hardware roundness. So if you select this function and like a this all will be called. Similar way of roundness 30, then this will be called. Whatever bottom is there called. When you select annual roundness 20, so I think it will be increasing the roundness size. Okay, let me go to the static. In static, there will be like a line width size. Okay, this is like a process line with one. So here, when we call this, so by default they are setting a line with one and some different color. So for line colors something, and I think both are same color. So the color is indicating in the hexadecimal. Okay, like I think RYB red, yellow, GP or okay something like a hexadecimal here it's indicating. So we can suppose if you want like a Hannibal, sorry, a line size with 1, 2, and 3. If you want to have a 4, you can copy paste. Okay, first let me select this 3 and show you. So this is the A underscore process line with 3. So it has some dedicated value and color. Okay, so for any shape, like if you are going to create any replay, uh, this is the style sheet which we need to select from the particular path. So this is selected that sp.css under HMI solution pack CSS sp.css file is it's mapped. So which means the same file which we have seen. Here we have sp dot sp dot cs. This file is mapped there. So from this file only, we have all the function called CSS function. So this all CSS functions are available here only. If you select a turbine, it has like a this is the function. Under this function, these are the color and the lines size thing will be there. Line color, fill color and the line color something. So now once I have imported this file, I have created a line. Now I can go here and I can select the what is my style. This okay. So here I can select that process line with size 1. If I want, I can select here. See, in that function, like what we are seeing, this is for static. So in static, we can see that a process line with 1, process line with the 2, process line with 3, and this is for observation. I have prepared with my name PP. So where it is available, not I think in this part. See, so here I have not created. Okay, this is the one PP what I have created. So here line size is 10 and I have changed the value instead of default value I have changed here. So when I call this 10 pp, then it is based on this, it is correcting. So I am deciding what should be here 10 pp. So here line size is high. So that's why this line size become a high, line width become a high, and the color also changed. Okay. So if I select this, here we can select some line size with 2. So this is a default like a black color, and size will be 2, and I think it will be 3 here. Here it is like a process line with 3. So similar way we can call all the we no need to go and select which color to be here. Okay, and no need to select here. Okay, we can call this uh, a line and we can decide which color. So by modifying that text file, we can do assign which color and what is the line size. By okay, we can configure from here based on the requirement. So this is like a cascade style sheet. So this is like a cascade style sheet for pump. If you select this pump, then it's a bad. When pump others means it is having different type of colors in hexa. Okay, the fill color and the line color. Okay, this is the cascade style sheet. All shapes in the HMI solution pack make use of cascade style sheets feature. So all shapes it can be used. Allow the definition of the color as well as many other objects property settings to be controlled centrally. Okay, style classes are applied to the objects in the display, such as a process line, a text, etc. So once the CSS, the presentation of the display objects can easily be implemented, controlled, and maintained and modified. On a cascade style sheet linked to the one cascade style sheet linked to a display, each cascade can define many style classes. So these are like a sp.css file, which all the functions are imported, which is available in the same folder. We linked up a .sp.css in the graphics display. So sp.css has a references to other standard and custom CSS file. So HMI Web Solution Pack has light, dark, and normal CSS themes. So themes to select from the as applicable to the project philosophy. So it has three different themes. We can see in a custom display also. Even here, this is developed based on the different themes like uh, the three different themes, dark or normal or light. I'm not able to see that one. Okay, so this all shapes are developed with the three different themes: dark, light, and um, normal CSS themes. Okay, I'm not able to see here. So these are three different themes. So CSS also has refers to the background color and the associated focus and the yoking. So points are linked to the custom properties. Each and every shapes have a custom property. Here we can link to the points or tags here. Okay, I understand different options in the customer, like by seeing the name. Okay, we can so by remaining properties will be like a default. It has mapped with some different uh, options. So if you want any customized, we can change it from here. Faceplate, like a need for a uh, the need for a faceplate is like a faceplate is a specialized type of pop-up. When you if you click any tag name or any text will create a faceplate. So standard system faceplates are available in this particular path. Okay, use the point information from an object data type for access to the parameter values. Shapes may not show all details, and the navigation to detailed display is at TDS. Faceplates show more details, easy to access. So mode selection and commands can also be done from the faceplate. So by here, as you can select a mode, okay, mode selection also we can done. So customization shapes customization should be kept to minimum. Implementation using standard shapes and faceplates is recommended. So Honeywell is recommending we should not do any like customized shapes. So it is recommended to use the existing whatever it's available in the solution pack standard shapes. So common shapes, custom shapes, and faceplates can be developed based on the only your project philosophy. If it is not available in HMI solution pack, if script needed to be added, modified in the process, create a new custom GS sketch and refer the subroutine in the same script. Okay, do not modify your standard GSH. So notice the naming of the adjoining custom shape. So if the standard shape was modified, try and keep naming in line with the original shape naming or as per a solution pack standard for better understanding. So this is like a basic of the scripting. I shown you where we can write a script. So how to view displays online, like select to current static or rotate station, or we can set with a station number. Okay, select if windows are multi-window or single window in case of safe view. So when it is a safe view, it's a multi-window. Normal case, it's a single window. So graphics name plus enter, then it will open in the graphics. Customize toolbar to add a easy access to graphics. It's like a sample diagram. It's like a detailed display of the station, alarm group configuration. So it's alarm groups. That's it about a HMI solution pack. Just I will create one small. Already I have a C300 in online. So just I will show you how to create and how to view for downloading, how to assign IP. So this is a control builder which can be launched from the. Again, I'm not able to. So from configuration studio, by selecting this configure process control strategy, control builder will be launched. Once we launch a control builder, if you are configuring a new controller, then go on like a right click root. Okay, select the controller. There are these different types of controllers available. Just I will select C300 controller. Okay, and we can provide so any name is the demo C300. Okay, okay, this is the controller name and like item name we can provide. Here we can assign asset. So here normally in if we take any Experion cluster, so everything will be in the same network. Only the device index will be vary. Okay, I am assigning right now like a 253 something. So automatically it is taken the IP by using the boot P. So this is the network IP. This is the device index. Okay, from where this network IP has taken. Okay. So here, this is the base IP is available 192.168.1.0. So this will be change to be a change for each and every node available in the network. So this is like a common network address. Only the device index will be changed, including server, station, controller, or any like a different types of controller. So for everything, this will be changed. So for our controller, physically, we need to do a dip switch. The dip switch setting will be there. So from dip switch, we can configure like a device index. So this is our controller which we have created. Once we created our controller, one control execution environment will be there. Two IO links will be there. Okay, we can confirm that IP. So it is assigned IP like a 253 something. Okay, and we can configure if any other parameter is required. Okay, and after configuration, I think this is the important thing. Okay, what we done, and we can select click OK, and we can download to the because if IP in network, this IP controller is available in the same network, and it having by using the dip switch, if the same IP is assigned, okay, then we can download this controller to the real controller. Once we have downloaded, it'll be like looks like here. See, okay, how we are having here. Okay, so it will become like this downloaded. Oh, normally, once you download, it will be inactive mode. We can right click and change to activate the controller. Okay. So once we have created the controller, we can create a CM control module. Where is it? Sorry, I'm doing from project side. So select here. You have to create a new control module for creating a program. So this is a control module for this particular controller. Okay, we can this and we can drag and drop the function block. It's got connected. So I'm sending some value data acquisition block. So from there it is going to PID. So there is another numeric value. I'm sending to set point. This simple logic I'm just making it. Okay, we can save this. So whatever we have created the control module, it will be available in the unassigned area. So we have to do assigned. We have to move to assign. Either we can drag and drop, or we can by selecting this. Okay, from this unassigned state to select the particular controller, and we can move it here. Okay, now the CM is okay. I don't want to be here because I cannot download. We try. I can add here. So now that CM is moved here. Okay, I'm just trying to download. No, it will successfully download or not. I think it's not downloaded. So this is like a while downloading, it will go to inactive mode, and uh, and after downloading, automatically it go to the post load. So for that, we need to check this box, change state to post load state after load. Something still it is not loaded. Okay. So this is how we can create a logic, and we can create a CM, and we can download it. Okay, let me play one video like a how to create a basic PID function. I'm playing this video. Just let me know if you're not able to listen audio.
In this video, we are going to configure a C300 PID loop control module. Your control builder should have a C300 controller, CEE, and 2 I/O links configured. You should also have your inputs and output modules configured as well. In the monitoring tab, you should have loaded your C300 controller, your control modules, your CEE should all be green. To configure a new control module, we will go to the library. We will scroll down to System, and beneath System, you will see Control Module. You will drag and drop the control module onto the CEE of your controller. A dialog box will appear. We will configure the tag name and item names. The tag name is the name that will be given to the control module so that you can detail it in Station. I typically copy the tag name, paste it into item name, and add _item. Click Finish. To configure the properties of the control module, we will double-click the control module. A chart screen will appear. I will resize the chart screen to fill my workspace. To configure the properties of the control module, I will double-click the white space of the control module. You can add a description of the control module if needed. You could also enter an engineering unit Next, we will enter the parent asset. The parent asset is used to assign the control module to the operator. To look up the asset, you can click the three dots, choose the asset that you want to assign the control module to, and then select OK. Next, we will configure the server displays. Select Server Displays. We will configure the faceplate that will be used with this control module. This is the faceplate that will be used on your station displays as well as your details. These faceplates are pre-configured graphics and can be customized. We can now configure if we want to attach this control module to a trend display by selecting the trend ID and the position in the trend. We can also select the group display that this control module will be attached to. We select the group number and the position. For server history, we will have to wait until the control module has been completed. Select OK to complete the properties of the control module. Now we will add the additional modules that we will be using. We will be using an analog input module, high level, and you will drag and drop the channel underneath the control module to the chart. Next, we will add an analog output. You will select the analog output channel and drag it to the chart. We will also be adding a data acquisition block. We will scroll up to data acquisition, select the data acquisition block, and drag it into the chart. Finally, we will add a PID module. We will scroll down to regulatory control, select the PID module, and drag it into the chart. If you would like to align your blocks, select the blocks you wish to align by drawing a box around them. You can use the alignment tools at the top of the chart. We will now configure the properties of the input block by double-clicking it. We can assign a name to the input block. You can also assign a description, but it is not required. Next, we will go to the Configuration tab. We can now configure the PV range, high and low, and the PV extended range, high and low. That is all we'll need for the input block. Select OK. Next, we will configure the data acquisition block. For the data acquisition block, we will rename it DACA DACA to be used with PV-related faceplates and scripting that use the DACA block. We can enter our engineering unit, as well as select the clamping option. You can also adjust the PV engineering unit range from the DACA block. In the DACA block, you can also add PV alarms. You will now add the alarm priority. From the Alarm tab, we can add debounce. There's an on delay and an off delay for the alarm. Select the OK button. We will now configure the PID block. Double-click the PID block. You can enter in an engineering unit and a description. Some faceplates look to the blocks for their values. You can enter in the PV engineering unit range low and range high. In this section, this is where you configure the mode and mode attributes. You can select the normal mode of the control module, as well as the normal mode attribute of the control module. The normal mode attribute is primarily used for sequential controls. You can also configure the mode that the control module will start at when loaded, as well as the mode attribute. You can set the safety interlock option. If you're not sure about these settings, you can always click on the question mark at the top of the block, drag it down to the selection box, and a help window will appear showing you the different settings. This works in most cases. We can now configure the algorithm for the PID block. From the Algorithm tab, you can set the Control Builder algorithm type, the control action, as well as all the other PID parameters. We can configure set point settings from the Set Point tab. From the Set Point tab, we can set our starting set point as well as the input range for the set point. This will limit the operator to only using the set point from within the range. We can also enable the PV tracking. This will allow the set point to track the PV for a bumpless transfer. We will now set the output settings from the Output tab. We can set the high and low percent as well as the control variable engineering unit high and low. We will now set the output alarms from the Output tab. If you would like to adjust the block pins, you can select the Block Pins tab. From here, we can add any additional block pins, select the pin positioning, add. It will add it to the pin list. You can also adjust the positioning of pins by selecting the pin and using the arrow keys to move the pin around. You can also select the pin positioning by changing the location From here, we are done with the PID block. Select the OK button. Now I will configure history for this PID control module, but first save. Double-click in the chart white space, then select the Server History tab. Select the parameter field. You can enter in the parameter that you wish to historize by typing it, or you can select the three dots at the end of the field. You can look up the point parameters. Select OK. Select the history collection rate. You can also add in any additional parameters by selecting another parameter field. Select the OK button at the bottom of the window. We will now assign the channels to the input and output blocks. Right-click the input block, select Function Block Assign. A dialog box will appear showing all the available channels. But be aware the channel numbers may not always be in order. If the channel was previously assigned and then unassigned, it will move to the bottom of the list, as shown here. Once the channel is selected, click the Assign button. The channel will now be assigned to the block, as shown here. Now let's do the output block. It will be assigned using the same method you used for the input block. I will configure the output block by changing its name. In this next step, we will wire the blocks together. There are two methods I will show you. The first method is to select the wire connector on the toolbar. Then select the first pin you want to connect to the second pin you want to connect. The wire will be connected. The second method I will show you is the double click. Double click the pin of the first block and then single click the pin of the second block. You can move the wire around by using the wire handles. I will wire the remaining PID block to the output block. I will now save my work before downloading. You will notice when the chart window is open, the download option is grayed out. Close the chart window prior to downloading. The download option now appears. In the project window, if you expand your control module, you will see all the blocks that you have entered. You can download the control module by selecting the control module and then selecting the green download arrow. A dialog box will appear showing you what you're about to load. At the bottom of the dialog box, you will see a selection for change state to post-load state after load. At the top of the dialog box, you will see a required state and a post-load state. Note required is inactive and post-load is active. I will not select the checkbox and select load. The module will download and a progress bar will show. Once the control module is downloaded successfully, it will be added to the monitoring window. If you expand the CEE in the monitoring window, you will see your control module along with the blocks within it. Notice that the blocks are blue. That's because they are idle. I will activate the control module manually by right-clicking the control module and selecting Activate, Selected Item. You will notice the control module is only stated, not the inputs and outputs. That will only activate the control module. If you would like to activate the entire control module with inputs and outputs, you will have to download with contents. I will inactivate the control module first. Now I will right-click on the control module, select Activate, select Item and Contents. The control module and the inputs and outputs will show. Select Yes, and you will see the control module, the inputs, the outputs will all become active. The control module is now created and downloaded to the controller. It can be added to displays, custom faceplates, and used in station.
Okay, we may take like a 15 minutes break and then we will meet again after 15 minutes break.
Could you please share the record with us?
Sorry?
The record, meeting record.
Yeah,
Could
yeah,
you
I
please share
will
it
be
with us?
sharing. I will be sharing recordings.
And the record of yesterday also.
Sorry?
Yesterday
Document.
record also.
Yeah, yeah, both will be shared.
Okay, thank you so much.
It will take 1 or 2 days. Okay, I will be sharing all the people.
And
Okay, thank you so
presentations
much.
here, please.
Yeah, sure, sure.
Thank you.
So if you
Okay.
share means you share the link, right?
I will be uploading in the digital university and from there people has to download it.
And, because I not know how to learn this.
Sorry, you don't have access.
Previously you upload some videos, but I don't learn them. Because I don't know how to
No.
learn the videos.
No, can you speak loudly, please?
So previously I did some sections, but I was not download any videos from that. I don't download
Okay.
any videos.
No, means like whatever I have shared previously, you are not able to download,
Yes,
or
I
you are
don't know how to download. Can you?
okay. I think yesterday I have shared on link. So will you able to register in that to enrollment?
Which link?
Let me share it again. Okay.
Okay.
So this is the digital university link. So here only I will be uploading the documents and the videos. So what I am requesting, you just go here and try to do your course enrollment for these 2 days.
Okay.
Okay, then from there, suppose for mm, logging into this, first you should have a account here. So for creating account, let me share one more document. Where is the document? Okay, let me share the document. Okay, I'm not able to. So follow the document. You do register in this champ. Okay, after that you can access this link. It will redirect you the login page, and after login you can do enrollment for this course. Once you do enrollment, no? So from there you can download it.
Okay.
I will share the steps for how to create a login.
Okay, sir. Okay.
Okay, we will meet after 15 minutes. Hi all, welcome back again. So now we will discuss about like a UOC controller. So before going for UOC controller, let me show you how the hardware looks for UOC. So similar, this is called like a control H PLC, but for UOC also like the same hardware which we are upgrading the firmware, and we are using it as a Experion LX controller. So only the difference is we will be upgrading the firmware for this. So this is like a CPM module, under this is supported like a 4 chassis, 8, 12 chassis with like a redundant power supply or redundant CPM. Okay, so they are all chassis based. So this is like a rack and a chassis based. So while configuring we need to configure rack and the chassis. So we need to mention the rack number and the chassis number. Sorry, chassis number, and what is the chassis, what is the rack number the module is inserted, and it supports like a topology also, which means I will show you a network topology diagram. So this supports like a star topology and a ring topology. Similar way, while configuring extended I/O modules, we need to select the supported for a star or ring topology. Okay, so this is the same hardware for a UOC controller which we will be using. So now we will start. So now we know about hardware, how it looks. Okay, so UOC like a basics, the unit operation controller is a high value, low cost, which means like cost effective, rack based process controller. The UOC can be paired with a virtualized controller called virtual UOC. Yeah, the UOC integrates natively into the Experion PKS DCS in a fashion parallel to the that of the existing controllers such as a C300 and a C200. So like a C200, C300, it can be integrated with the Experion PKS using CDA protocol. It uses the same control execution environment. It's like a which already used in the C300 and the C200. And the software for the integration also same. Like a control builder only, we will be making program for this. Okay, it can be configured on FTE. The control edge, what we saw like control edge CPM can be used as a control edge or like a control edge UOC to use the same to use the CPM as a UOC. We need to upgrade the CPM with the UOC firmware image. So as I told earlier, so control edge PLC only we are using it as a control edge UOC controller. So only thing the CPM hardware firmware should be upgraded. So UOC to PLC conversion is currently not supported. Once you upgrade it as a UOC controller, then reverse firmware downgrade is not till now it's not supported. Maybe in future it will be possible. The firmware upgrade is done using the firmware manager software. Okay, so this is the like a basic setup where we can set the base AP which we saw in the C300 configuration. So this will be like a basic setup. It can be done from this system preference and embedded FTE. Okay, and like a UOC controller also we can assign the IP. Okay, once we assign the IP from the base network, it'll take that and it'll form of IP. Just a second, I am getting some noise. Okay. So similar way, it will form it will take a network address from the base IP and we can form the net. So these two are like in Control H PLC, we will be having two downlink IP. Okay, so if you want to enable like I1 IP, we can enable this and we can mark it. We can enter the IP address. So how to add a IOS? Maybe I will show you from the control builder. So default rack number is 0. Can select a rack type. Okay, and select a correct rack number. Select a correct IO topology. Select a correct rack number, rack IO topology, rack type. Okay. So this is what I told you. Like it's a rack and a chassis based. So chassis and like a rack based. So while selecting, we should first chassis will be like a rack will be like a number 0, and can select a rack type. Okay, and select that slot number. Again, we need to provide a like a star topology or ring topology here, and which slot it is. This is like a execution scan rate. Okay, and from here we can provide we can configure the IO names, IO tags, and we can configure this ranges, a channel configuration. So this is like a function libraries. So we have an extensive library for all commonly required function blocks. Each block has a defined set of applicable input and output connection. Details of the blocks and pins can be found in the manual of the control builder components theory. This is a basic PID loop. So like how to download. So from IO reference blocks only, we are assigning the input and output from here. Okay, so we can, if we don't have any IOs, we can use the simulation method also. Again, a DACA block for reading values from the analog input. Okay, mainly the DACA block will be mainly used for scaling the input value and generate alarm if like a input value cross the limits. Okay, we have a DA, digital input data acquisition like DAG quick block. It reads, it helps to read a digital input, and it mainly used for read value and generate alarms for digital input. There are common blocks which we are using like a PID blocks. So already we saw in the like during our C300 programming time. So just quickly I will go through like the PID block is a regulatory control block that operates an proportional integral and a derivative controller. This block may be used in a single control loop or with a multiple PID in a cascade strategy. The PID block has two analog inputs, PV and set point. The differences between the PV and set point in the error, and this block calculate a control output that should drive the error to 0. Select from if it has like a 5 equation, so we can select any one for the PID action. Okay, PID block provides an interface to analog devices such as a solenoid valves. So PID like it's a manual input PV and SP. Okay, a main output of the PID block. Goal of the PID is setting output in order to minimize the error. Okay, it has like a modes, manual modes, auto mode, and cascade mode. Okay, if a mode is in manual, output may be stored by the operator or a user program. PV and set point are ignored here. If a primary exists, then it goes to the initialized state. Similarly, auto mode, if a mode is in automatic, SP may be set point may be stored by the operator or user program. If the primary exists, it goes to the initialized state. SP contains set point value in the engineering units, and SPP contains the value in the percentage. It's like a set point and a set point percentage. Cascade, if a mode is in cascade, SP is pulled from the primary, set point is pulled from the primary, and if the primary is off control, then that is inactive or initializing, the connection is bad, the PID block invokes the timeout processing. So this is the like a mode where we can change three different mode. Okay. So this is a safety interlock option. When in case of any safety issues happened, what is the output, like a set hold, or it will be like a 3 to 4 options, set minimum value, set high value, like that. So when it is a bad control option, then what is the action item? No set, or the set hold, or bad, like a set safe value, or low value, high value. So these are all like the equation. There are equation A, B, C, D, E, each how it is calculated. So based on our requirement, we can select the equation, and in this main tab we can configure a PV accepted value range. When PV is in manual, so like what is the output here? Okay, so this is acceptable PV range value. So these all are like if you check this checkbox, then from the PID block, modes can be changed by the logic. So this will be having like a pin or some input value. So from logic, we can enable or disable. We can change the mode from the logic. These are like a P, I, and a D values. Okay, when it is selected as a direct, the PV is above set point, then output will rise. When it is a reverse, when the PV is above the set point, output will decrease. So set point low and high range here we can configure. Okay, when it is enabled, like enable PV tracking means when it is enabled, SP will follow the PV. So these are like output ranges limits, okay, which we can configure in the PID block, and safe output value. Like in case of any safety input happened, so what is the output value to be PID block? So these all are the PID block pins. So next is like a device control block. So device control block is a multi-input, multi-output function that provides an interface to discrete devices such as a motor, solenoid valve, and a motor operated valve. So it allows to configure up to 4 inputs, 3 states, and 3 outputs, allows to have a maintained or pulsed output, and the facility to configure the interlock and permissives, facility to configure the device alarms. This I will explain how it is working. Okay, before that, let me just check. So just we will see how to create a UOC controller. Already there is some controller. So just go here. Similar way like a new controller, a UOC. I am providing UOC2. Okay, item name can be okay, select assert. So I don't have a real control, just I'm showing like how to configure because my control is corrupted. I'm not able to download. So just let me set to 81. So automatically it will take this network IP. Why it is configuring 25. Okay, so it's taking default as a 25 IP. Okay, so here, so this two IP here we can configure a IO chassis, IO link IPs here, but right now I'm not going to do. So I'm just removing. Okay, we can select if it is a module is redundant. So now nothing but we are configuring the CPM. Okay, so we can like this time selecting here. So now the controller I have created. So freely controller is available in the network. We can download it, but I don't have any controller. Let me try. Yeah, because the whatever I had it's corrupted. So now I will assign the. Now we have created a CPM, but we need to assign the chassis. So we can go here. Control H 900. I hope because this is belongs to 900 900 family, we can go there under controller rack. So we have to drag and drop the controller rack. Okay, UOC. C2 controller rack. So by default, this will be like a controller rack will be as a 0. Okay, so we can select it's a 4 slots or 8 slot or 12 slot. So I'm just selecting 4 slot. So I can also assign the assert. Okay. So now we have created a 4 slot chassis and already we know that in CPM is available. Okay. So we can add IOs here. So for C8 IOs, I am just adding universal IO here. So we have a multiple IOs. I am just adding universal IO. Okay, control rack, universal. I and this might be slot 1 or 2, I think. Okay, I have added a IO module in this. So since we have selected a 4 slot, we will see which slot it has taken. Already CPM is there. A CPM will be in one slot, so I am selecting slot number 2 here. Again, I'm assigning the asset. Okay. So now we have created a excuse me. IO module for so still I think out of 4 slots, 2 are occupied, still 2 are pending. We can create a 2 more IO modules. Now suppose if IO module is available in the like a topology like a star or extended IO modules, then what to do? Like we can go here. So first what we selected is a controller rack. Now there will be like a IO rack. And just a drag and drop here. So first one will be like a 0 chassis. Now I am selecting 1. IO rack 1. So now IO rack 1 is created. Now I need to add like again same like universal IO to here. Okay, before that I forgot to do something. A universal IO slot number 1. So after adding the IO module, we should select a slot number and topology. So it's a rack number will be like a 1. And here we need to select from like a controller rack to IO rack, how this topology is considering or star topology. Okay, I'm selecting star topology. You can have like a number of slots, so 4, 8, or so I'm selecting 4 slot only here. Okay, again assert. So now I have configured the IO rack. Now I'm going to IO module. So this IO module have a 6, I think 8 input. So this is like a channel configuration. Okay, we can create like a thing. This is a universal analog input, not a you would say okay analog input 1, analog input 2. Okay, let it be. I have configured 4. Okay, 1, 2, 3. I have configured. Let me. I will try use this one. I have added a second module here. We'll go here. Okay, so I want to use this one only, but by mistaken I selected universal analog input. So here I have an option for analog input, to analog input. I am selecting to analog output, to digital input, to digital output. Okay, so remaining will be share. So to AA, to AO, to DA, to DO. So this is the advantage of a digital, sorry, universal IO. They can select anything based on our requirement. Okay, I am selected this digital input and I am just saving it. So this is how we can do IO allocation for this. Okay, now I will make one simple program. So before that, let me create a CM here, control module. So whenever you are creating control module, automatically it will go to unassigned state. Okay, which we should assign to the particular controller. Okay, so demo city, I am just mentioning CM on control module 1. Okay, no need. I'm just selecting asset. Okay. So let me we have already seen the PID function block. So just I want to show you like a device controller block. Okay, just save. So where it went. Okay, this is a demo UOC2 CM1. Okay, I'm just I'm selecting here to assign. We can drag and drop directly here. Okay, now I want to assign here. So what is the CE name for this? So CE name is UOC 797. UOC 797. Select here and assign. Okay, so it is assigned here. The CM is assigned here. Okay, so now let's discuss about this device control block. So this device control block is it will be used for provides an interface to discrete devices like a motor, solenoid valves, and motor operated valve. Okay, it can configure as a 4 input and 3 states and 3 output. But let me take like I am selecting here. So I am selecting like a two state in two input. Okay, two output and two state. Okay. So now this will be like a we are so normal function will be like a suppose if you want to run some pump or open a valve or open any run a motor. So we will be giving some command like a start push button. Once this function block receive the push button command, it will give a output to the field, one output. So output will start the pump. Okay, then again the pump once the pump is started, the running feedback will be receiving to again as a input to the this function block. Once the running feedback is received, then it will wait. Suppose if the running feedback is not received, they have provided the comments to the field, which means we have provided a start command to the field, but pump is not started. That's why we not received the feedback. Then it will create an alarm. Okay. So this is the one case. So once we received the feedback, then again after some time we are providing the stop command. So stop command and stop command is the another input. Okay, feedback is another input. So now we have provided the stop command. So the stop command again will go and it will create a one more output. Okay, so those output will go and stop the pump. Okay, then once the pump is stopped, we will be receiving that uh, a pump stopped feedback. So once we pump is stopped, then that's what it's a normal behavior of the this function block. Okay, so we are having like a two state here. So for example, we are this state one is start command. Okay, state two is like for stop command. Okay, so now when both the commands are not there, then we can consider as a in between. When nothing is there, can be like a bad. Okay, so maybe while executing, maybe we'll understand clearly. So next is like a digital input. So this is the digital input. okay, like a which we are seeing as a feedback from the field. So we are having, we consider two digital input for a feedback. So when we have a two, one will be for a running feedback, another one will be for a stopped, like a stop feedback. Okay, and when both are there, it's a bad condition. So that's what we need to select here. When both are not there, also it's a in between. Okay, I mean they assume that the first input, digital input one, is we are considering as a start feedback. Okay, and when the digital input 2 received and this input is 0, then we are considering as a stop feedback, which means from field we got a input this, then we consider as a started. From field we got a this input, then we consider as a stop. But is there anything possible like a both the inputs, which means start command, start feedback and stop feedback, both is possible? No. When we are having both the input, then it is a bad state. Similar way, we have issued the stop command. Okay, so what will happen? It is started from suppose like if you provided the start command means the first step will be like a stop, then initially it will like it will try to stop. So we will not get a feedback like a start feedback or stop feedback, which means like it is trying to move from either start to stop or stop to start. So if we don't have this feedback, both the feedback, then we can consider it's a in between state. So this is what this is two state. We can select a single state also. Instead of selecting two inputs, we can consider only one input. Like when it is coming on, then it is a start feedback. When it is off, then we can consider as a um, off state. Okay, if you select a single, then we have only two input, like a only one input, but it's a true state from the field. In it is a 0, means pump is stopped. When it is on from the field, then it is a pump is started. So it's like a start feedback. So this is how we can right now I'm considering two input. Okay, as I mentioned earlier, click OK. Okay, so here there are some pins which not selected by default. So I'm selecting those pins. Okay, I think OPCMD. Okay, OP command is 0. Okay, when this command is like this, pin is like a array. So I am selecting as a input. Okay, and I do first I want to select a 1. I'm adding as a input here block. It's added here. Now I am adding as a 0 here. 0 bit I am adding as a input here. So 1 and 0 are added. Okay, similar way, digital input 1 and the digital input 2 is already available. So I have a only digital output 1. Sorry, already we have a digital output 1 and digital output 2. Okay. So now let me explain how this normal function will be like a we take sorry that I go references. And a digital input reference. So I have added two input from the field. So I am giving one for OP command 1. Okay, and here to OP command 2. I'm assigning input parameter like so what I have selected this is a control H 900 family. So I'm selecting this option, and you can go here. Okay, it's getting hanged. Uh, if you use the player, also the similar problem. So I'm closing and opening again. Before that, there will be some active locks. So I need to clear that active locks because of this issue. So the active locks, let me clear. Clear. Okay. Let me launch again. Okay, so I think it's going to, it's not saved. So again, let me add a pin. And so I'm adding as a 1 for a start and a 0 for a stop. I need to add again OP command. 0 as a input. Okay, both are input. Okay, now I want to add a DI, both are there, and DO, both are there. Okay. DO1, only DO1 is there. I need to add a DO2 also. DO0, okay. Here we have to mention a DO0 and 1 and 2 is there, which is going to field. Okay, so let me like what I am trying to say, like from a field, if we have a digital input, if we connect to the OP command 1, thing gone, start P. So this is for start and stop, and we can select here to state when it is in between. So when we received this one started, when we received this is stopped, it's a bad, and it's in between. Okay, output will be like a this is for start and this is for stop. Okay, so let me explain. So from field we are getting push button like somebody wants to start a pump. So we will be getting a digital input here. So what this OP command will do, okay, directly based on here, like um, so OP command will come here and it will check it is a start. It is assigned to the, okay, this output, digital output. Okay, so it will enable this DO1. DO1, it will be go to the field start command. So once the start command goes to the field, so output will like a pump will start. Okay, so what once it's given the start command, there will be a delay. Uh, okay, alarms. So here we are having like a delay. We can mention like a. I'm not sure how timings. Okay, I'm mentioning like a 1 second or 1 minute. So after this delayed time, till this time period, it will wait for the this digital input. Okay, so the digital input will be like a start feedback. So digital input one we have selected here. So when the digital input input one, if receives, then it will assume that I got a start feedback. If it is not received after we have enabled this output, digital output to the field, but I have not received the feedback here. That means uh, pump is not started. Okay, so it will generate alarm here. Command disagree alarm. This is alarm PV alarming. So command disagree. I have provided the command, but I no devices not agree to the commands. Suppose if it is we received the start feedback, then everything is fine. Now next step, like a OP command to like that's what the second pin. Here the second pin we have marked the second pin as a stop condition. So when we press that OP command 2, so that will that pin will become a high, then it will assume that we are going to provide the stop command. So what will happen? So this stop is mapped to here output pin 2. Okay, so it will what will do? This will enable this stop command. Okay, it will enable the digital output 2. So when the digital output is enabled, like if we go provided to the field, then a pump will already it is a started condition which will try to stop. So we will be losing start feedback also. Still pump is not stopped completely. So we will not receive the like a stop feedback also, which means we may not receive both the feedback here. Okay, start feedback also not there, stop feedback also not there. So we can assume that it is an in-between stage. But this in-between stage will be like a how long? Here we can provide the time after some time. So time period. So this much time we can it will wait for the feedback. If feedback is not received after a particular time, again command disagree will be alarm will be generated. Okay, so but if this feedback is received within a time frame, then it will kind of assume that they have received the stop feedback. Okay, uh, uh, now so this is another alarm. So either pump from field you will get a run feedback or a stop feedback. Both is not possible at a time. So that we are having a bad and it will generate alarm. Okay, I think this is the functionality of this function block, which will provide the digital input for which we saw in the PPT, like such as a motor solenoid valve and motor operated valve, which will provide the digital output here. Okay. So this is the block pin, like which I said, OP command 1 for a start, OP command 0 for a stop. These are the in between stage. I think this we already explained in the function block. So this is used for any discrete devices. Okay, motor solenoid valves and motor operated valves. So you can define actual PV state based on the feedback input or OP states that will command output. Okay, also block offers permissive interlock, safety interlock, modes of the operation and alarms. So additionally, we will get a like a permissive interlock from the field. So if permissive interlock is there, then only pump will start. Start command will be issued. If not, start command will not issue. And the modes of operation, safety interlock also same condition. Like if during pump running time, if any safety interlock occurs, then a pump should stop immediately. Okay, and the modes of we can configure the alarms. Okay, which we saw already, a command like a command disagree alarm. So we have 3 to 4 alarms are there. So CB tag name is available in the RTDB. So you can ask station for directly. So for diagnostic purpose, we can call from the station. So these are the various options. Okay, define states for block number 1 here. So this is we already did done. Based on the number of states selected, you can define all possible states such as in between bad and number 2 PV state. So based on the input combination, what is the current value of the block? Okay. And the example, if no inputs provides feedback, we are in between. And if both inputs are on and we have a bad state. So it's like a feedback. Okay, output states a defined state of the output, a safe state and other settings. So device control it's a mode operator. Only the operator may command the output state, and program it is a program and only the function blocks such as the logic blocks, SCM programs may command the output state of the setting up. And the normal means like a setting specified by the normal mode attribute is assumed. When the local man parameter is on, the output state tracks the PV state, and if it is settable state, if the PV is non-settable state, the output will be set to the safe output. So these are like a device control, like a P1 permissive interlock. It's a array input 0 to 2 we can give permissive interlock. One permit for output to be changed. Okay, if it is a 1, it's a permits for output to be changed. SFT override interlock. So when it is 1, then it's like a some safety issues happened, then we need to provide a safe state output. So OA output state override interlock, and if it is a override interlock occurs, then forces the output to decide the state. Bypass the parameter to bypass the permissives. Suppose if we kept in the bypass, then none of the parameters will be considered. Okay, override interlocks, but no safety for okay, so we can assume for override interlocks, bypass can be uh, assigned for permissive and overlaid interlocks. So which means we can no need to consider this, but safety interlocks we cannot assign the pipe. We can bypass it. So this is the like alarms, different type of alarms, command and disagree alarm. So if feedback we not received, then command disagree. Okay, but when generated, when the current active state fails to change. So like this digital output is not changed, then it's a command fail. Okay, uncommand change alarm. We have not provided the command to the field, but it's changed like a digital input. We got a feedback received. Suppose we not provided the run command, pump is in stopped state, but we received the run feedback, then it's uncommand change alarm. Bad PV we saw already, like a both run and stop feedback is received, then it's like a bad PV. Override alarm in the active interlock causes the output change. So these are like a safety input or something like alarms. So these are some example of a 2 input and a 2 output state. Again, single input state 0 and 1. Single output. So this is how we can configure. This is OP command one from start button, start command, stop command. These are like a feedback, running feedback and stop feedback. So the here DO1 and DO2 pin will be there. This will be providing start command, run command to the field. So here important things like orders in CM, how many block pins should be visible, and the configuration parameter, monitoring parameters, function blocks color. Okay, and upload and okay, I'm not sure what is this. So we can okay, we can do the checkpoint. Okay, and we can schedule checkpoint, archive checkpoint, save checkpoint, restore checkpoints possible. So like in control builder, we have a controller application solution pack, like how we have a HMI solution pack. So there we will be having templates. So those templates we can make an instance, and like how like already HMI, we have a standard display libraries available. In similar way, here we have logics libraries is available from the like a CASP. So from there we can create like a instance, and those instance can be used for our programming purpose. So this is like a CASP naming convention. So it will be considered as a 6 character. So there is something like a device controller means it will be mentioned as a device with the two double X. Okay. The first X is the number of the input, and the second X is the number of the output, which means device 221. Okay, and this A is indicating like a 2-digit counting number of other functional differences. So these all are like this S8 means we have like a S8 or a C series. This is a series 8, or a generic, or a series, or a PMIO, or foundation field bus, or Profibus. So this will indicate. And the C means control module. Okay, others possibles are like a S for SEM, U for UCM, R for RCM, B for cab. Okay, so the T indicates template version of the module. Okay, Y is like a CM or a SCM or cab number with the given strategy. Okay, so these are the templates will be available. Okay, so like this is the like a CASP. There are many templates are available. We can right click and we can create a instance. Okay, and so it will be created in the unassigned. From there we can use it. The condition will be like a the user defined requirement specification, like a basic control schemes can be developed into the template and a UDT. So once you create an instance, so it will be a UD user defined a template can be used quickly building like a strategy in the project for the creating similar set of logics and common obligations. So so the general so the purpose is like a if template is already available, if you are going to use the same template, so it will be like a we cannot make any logic mistake. So already that template will be tested. So pre-testing of template with the customer for implementation of the bulk control strategies. So no need to test it here. Guarantees the design logic functionality and the reduction of the testing time of the child CME instances. Okay, and reduce the effort of analyzing during the FAT. Okay, and it's saving cost since we are using the template, not developing from the scratch. So it saves the cost also, and can add other function blocks into the child or instance. So once we create a child or instance, we can modify or we can add a function block. Okay, but the that changes will not reflect in the parent. The standard or consistency function blocks and the pin connectors arrangement in the similar set of the logics and loops. The specific parameters can be propagated into the instance, can export and import to the other project, not a licensed option. So modification of the typical function or configuration can be done easily using UDT, either can by creating the new template or modification of the existing template. Okay, we can easily develop by creating the instances instead of developing a new control module from the scratch. One thing like once you create an instance, we can modify, but that we can add any function blocks that will not reflect in the parent. Okay, but if you are adding something in the parent, that will be reflected in the child. Okay, these are our UDT. Okay, think that's all. Let me play one video for the UOC. Next, I will just play video for SCM, how to configure.
In this video, I will configure a virtual UOC controller. Virtual UOC allows you to virtualize the UOC so that all physical EPMs, I always add the index number to the end of the field and you will see the full IP address, which is the first 3 octets of select control strategy to your server. Select control strategy. Select configure process control strategies. Control builder will start. Sometimes control builder will run minimize. Just select the control builder icon on the taskbar. You will see here in Control Builder I have a C300 controller already configured. We will be adding a virtual UOC controller. Before you add any controllers, you must set the base IP for any process controllers. To do this, you will select Tools, System Preferences, Embedded FTE. Here you will see the base IP address, which is the first 3 octets of a controller's IP address. You will also see subnet and SNTP settings. You can change the settings by selecting Edit Network Parameters. Once you have added a controller, you can no longer change the base IP. The procedure for setting up a virtual UOC controller is identical to that of a UOC controller. To add a UOC controller to Control Builder, select File, New, Controllers, UOC Controller. You will first set the tag name of the UOC controller. I typically add the device index number to the end of the UOC controller, and if it's virtualized, I usually begin the controller with a V. I also copy the tag name and copy it into the item name and add _item. Next we will set the device index. This is the device index that you assigned the controller when you added it to VMware. Select any other field and you will see the full IP address of the controller. You will see it is the base IP plus the index makes up the controller's IP address. In this video, I will not be adding any real I/O to this virtual UOC controller. If you are adding I/O to your virtual UOC controller, you will have to set the downlink address configuration and you will have to enable DHCP server along with an IP range. I will disable downlink address configuration since I will not be using real I/O. It can always be added later. Select OK. The UOC controller has been added, to the project side of Control Builder. Select the plus sign next to your controller and you will see the control execution environment. Double-click the control execution environment and assign it a tag name. Copy the tag name and paste it into the item name and add _item. You will now have to set the base execution period. It is very important that you select the base execution period for the OVF file that you used. I used a 500 millisecond file, so I will select the base execution period for 500 milliseconds. Select OK. The controller is now ready to be downloaded to the real-time database. To do this, select the controller and then select the green download arrow at the top of Control Builder. A dialog box will appear. Select the Load button. The controller will then load to the real-time database of Experion. In the Monitoring tab, you will now see your virtual UOC controller and your control execution environment. They will be blue because they are idle. To activate, right-click the CEE of the UOC controller, select Change State. From here, you can select either a cold or warm start. I will select a cold start. Select Yes, select OK. You will see the controller is now green because it is running. It is important to keep the virtual UOC VM running while you are using it in Control Builder. I will demonstrate what will happen if the virtual machine shuts down, and I will also show you how to recover it. I will power off the virtual machine. In Control Builder, you will see the virtual UOC controller turn red. I will now restart my virtual UOC controller. In a few seconds, the controller will turn yellow. You will now have to restore from checkpoint to restore the controller in the real-time database. To do this, you will right-click the controller, you will select Checkpoint, Restore from Checkpoint. You will see a checkpoint file. This checkpoint file was created when you downloaded the controller. Select the file, select Restore, select Continue. Select Continue again. The controller will restore. Select Close, select Close again, and you will now see the controller is blue for idle. You can start the controller by right-clicking the CEE, select Change State. I will select a cold start. Select Yes, select OK, and the controller will run again. Next, I will show you how to add I/O and how to build a control module for simulation. I will now demonstrate how to add I/O to virtual UOC. In this demonstration, I will add I/O, but I do not have real I/O connected to my virtual UOC. When I download it, it will show red for no communications. Control Builder will let you add and download I/O that you don't have but will eventually add later. I will demonstrate how to add I/O to the same rack as the controller. To add I/O, you will go to the Library tab and you will scroll down to the CE900 IO folder. Here you will see Controller Rack. This is to add I/O to the same rack as the controller. You will also see I/O Rack. This is to add I/O to an extension rack from the controller. To add an I/O rack, such as the controller rack, drag and drop it to the CEE of the virtual UOC controller in the place it into the item name and add _item. Select Finish. If you extend your CEE and extend your I/O, you will now see your I/O rack.
Okay, I'm skipping this since we already
To
saw
download
this.
the I/O rack, you will see here CEE of your. Since I do not have physical I/O connected to my virtual UOC, and you will see your new control module _item. This will be the tag name that it will detail, and select Finish. A category will be added to your. I typically dialog box CEE item. Drag and drop the control module item to the CEE of your virtual UOC controller. In the dialog box, you will add a tag name to the control module. This will be the tag name that it will detail in Station. I typically copy the tag name, paste it into the item name under Destination, add _item, and select Finish. A category will be added to your virtual UOC controller called Control Application. Expand that and you will see your new control module. Double-click the control module. You will see a chart appear. This chart is where you will build your new control module. Since I do not have physical I/O connected to my virtual UOC, I will use I/O references that I can later point to real I/O. To do this, I will go to the Library tab and go to the I/O references category. From there, I can see my AI, AO, DI, and DO references. I will drag in an AI reference to my chart. This is a placeholder for my analog input. I can later change it to an actual analog input. I will now add other blocks to my logic. For this example, I will add a data acquisition block to bring in PV value and add PV alarms. To do this, I will go to the Library tab and scroll to the Data Acquisition category. I will drag and drop a data acquisition block to my chart. Because this block may be used in a standard Honeywell faceplate, I will rename the block DACA. This is the only block that I know that you have to do this to. I can set my PV range. I can also add PV alarms. There are other changes I can make, such as clamping and adding other block pins, but for now I'll leave it as default and select OK. I will now add a PID block. From the library, I will go to the Regulatory Control category, find the PID block, and drag it into my chart. To finalize my PID loop, I will add an AO reference. To do this, I will go to the library, go to the IO references category, and drag and drop in an AO reference block. I can now connect the pins between the blocks. There are two ways of doing this. One way is to double-click the first pin and single-click the second pin. The second way to do this is to select the wire tool on the toolbar, then single-click the first pin and single-click the second pin. I will now wire up the last two blocks. Blocks on a chart, whether they're wired or not, can be moved around. Wires on a chart can also be adjusted. Select the wire, and you will see handles that will appear that allow you to move the wire around. Alignment tools can also be used. Select both blocks and use the alignment tools at the top of the chart to align blocks. Double-clicking the white space will open the properties for the whole control module. All control modules must be assigned to an asset. An asset is then assigned to an operator for control. See the video on configuring assets for more information. You can also add in descriptions and engineering units.
Guys, I think the same video I already displayed again, right? The same PID blocks creation. Got confused. Like the same video I have executed earlier also, I think. How to create a PID blocks. So I'm not getting any response. Okay. I think this video already I have played. Okay, I'm just seeing if anything is pending. Let me. So this control application, the advantage. Okay, this we have done. So sequential control module. Okay. So this sequential control module will be used in the batch process. So okay, it has a various steps. Okay, it's very difficult to explain. Let me play a video how this sequence will be executed. SEM will be executed.
.40 kPAG and PC16 at 1170 kPAG in automatic. To build the SEM, I will open up Control Builder. You will see here the C300 I/O and control modules are already configured. These control modules are the pumps, valves, and fans in my process. On the left-hand side, you will see here I have a loaded controller, the loaded I/O, and all of my loaded control modules. A sequential control module will command these control modules what to do in a specific order. There are two ways of building an SCM. The first way is you can go to File, New, Equipment Module, Sequential Control Module. If you use this method, you will have to manually assign your SCM to your controller. The second way you can do it is to go to the library and scroll down to the System category. You will then drag the SCM up to your control execution of your controller. You will see a naming dialog appear. In the tag name destination, you will name your SCM. For item name destination, I typically copy the tag name and paste it into the destination and add _item. Select Finish. You will now see if I scroll down in the control execution that the SCM is already assigned. There is no need to manually assign it. Double-click the SCM to open it. Double-click the Open SCM to begin the configuration. First, I will assign an asset to my SCM. The asset is used to assign the SCM permissions to an operator. Assigning an asset is a requirement. Optionally, I can enter in a description and an engineering unit for my SCM. Select OK. At the top of the SCM, you will see an invoke. This invoke tells the SCM when to start. Currently, the invoke configuration is hidden. To show the configuration of the invoke, right-click the invoke, select SCM Transition Object, and toggle the on and off. You now see the invoke transitions configuration. To add my first expression, I will select the plus sign. Remember, you can have up to 10 conditions in a transition. Double-click the condition. I will first select the main tab and enter in some information for this transition. I will enter in a name and description for this transition. I will now select the first condition. I will enter in a description for this expression. This condition can either be an operator action or a control module value. I will be using a flag block for the invoke. I can then assign that flag block to an operator graphic. You can choose to type in the condition or search for it under points. To search for it, select Points, search for the control module in the list. In this case, it's a control module called Flags. The block that was created was named C, and the parameter is PVFL. To quickly search for the parameter, you can select in the parameter field and start typing in the parameter name. I will select PVFL for PV flag. Select OK. For a transition condition value, I will enter in : equals, and then select 1 for on. Next, I will enter in my gates. Select the Gates tab. Since there is only one expression, I will only have one primary gate, which is connect. Since I only have one primary gate, I will select connect for the secondary gate. For more information on gates, see the SCM intro video. Select OK. My invoke transition is now complete. On the transition block, you can toggle between expressions and descriptions. I will now enter in a step block to start performing actions. To do this, I will scroll down in the library to the SCM category. From the SCM folder, I will drag in a step block. I will align the step block to make wiring a little easier. To show the step block conditions, I will right-click the step block, go to SCM Step Object, and select the on-off toggle. I will now wire the transition to the step block by double-clicking the transition pin and single-clicking the step pin. Double-click the step block. I'll enter in a step block name and a description. For step output, there are 3 enforcement order options. Here are the enforce order options. Select OK. To add an expression, press plus. Double-click the expression. I will start off by adding a description. And now build the expression. For most blocks, to change the output, the mode attribute must be in program and the mode must be in manual. Our first expression will be to change the mode attribute to program, our next expression to change the mode to manual, and our last expression will change the output. This order of operations will be used whenever a value needs to be changed for a control module. If you're not sure what the tag name is, you can look it up by selecting points. And then you can scroll through the list of points to find the point that you want to change. Here is the point 11_HC44, and here is the block AutoMana. For the parameter, I will look for mode attribute. By typing in M, it'll jump to the M section. Here is mode attribute. Select OK. Now the mode attribute has to be in program, but if I don't know the enumeration for program, I can look it up. Select the point parameter, select fetch enums, and you will see the enumerations in the lower right-hand corner. Program is an enumeration of 2, so I will do :2. Select OK. You will see the new expression has been entered. I will now press the plus sign to add another expression. Double-click the expression, and now I will enter in the expression to change HC44's mode to manual. This time I will enter in the tag name manually. Manual entries are always faster. So it'll be the tag name dot the block name dot the parameter and then : If I still need to look up the enumeration, I will select the point parameter without the : select fetch enums, and you will see the enumerations. The enumeration for manual is 0. I will then enter in a 0 at the end. I will now enter in a description. This expression is done, and I will select OK. To speed things up, I will enter in all the expressions and explain it to you. Here, the mode attribute for HC44 is changed to program. Then the mode for HC44 is changed to manual, and then the output for HC44 is changed. I then changed the mode attribute back to operator to allow the operator to have control again. For PC15, the mode attribute is changed to program. For PC15, the mode is changed to manual, and for PC15, the output is then changed. For PC15, I return the mode attribute to operator. Now for PC16, it's a little different. There are two blocks with modes that need to be changed. First, the fan-out block's mode attribute needs to be changed to program. Then the fan-out block's mode needs to be changed to cascade. Then the PITA block's mode attribute needs to be changed to program, and the PITA block's mode needs to be changed to manual. Then I will change the PITA block's output to 100, and finally I will change the mode attribute back to operator. For every control module, I change the mode attribute, then I change the mode, and then I change the actual value. If you'd like to see the descriptions, you can change it to descriptions. It is important to enter in the description information for this to work properly. I will now add in a transition to check to see if PC15 is greater than or equal to 49. From the library under SCM, drag in a transition. Align the transition and then wire it up. Enable the transition configuration by right-clicking the transition, select Transition Object, and then toggle the on-off. If you would like all your SCM blocks to always open up with the expressions being shown, you can do this by going to Tools, System Preferences, and you will see a checkbox for Initial SCM Step Transition Detail Visibility and select Shown. Select OK. There is a warning saying that you have to restart Control Builder. You will not have to restart Control Builder for this. Now the next time you add a step or a transition, you will see the configuration being shown. To add an expression, press the plus sign. Double-click the expression. I will toggle to the main tab to enter a name and description for this transition. Select condition 1. Now I can enter in my description for my first condition. And now I will enter in the expression. Remember, transition blocks only check things. This transition will check if PC15's output is greater than or equal to 49. If it is, then the sequence will proceed. Next, I will select the gates, and since there's only one expression, the primary will be connect and the secondary will be connect. Select OK. Now I will enter in another step block. From the library under SCM, grab a step and drag it into the workspace. Align it, then wire it up. To speed things along, I've already entered in all the expressions, but you can see I follow the same pattern. I changed the mode attribute to program, I changed the mode to the appropriate setting, enter in the value. Finally, I change the mode attribute back to operator so the operator has control again. And I continue this for HC44, PC15, as well as PC16. You will see the addition of one more expression at the end, line number 13. This allows me to send a message back to the operator. I will navigate to my flags control module to show you this message block. Here is the message expression, and it is linked to this message block. If I double-click on the message block, you will see the messages that have been added to send to the operator. I will be using these messages in future labs. We are now ready to download this program. I will close out all of the control modules. I will save my sequence. I will then close out my sequence. I will select the sequence from the Project tab, and I will select the Download button. From the Load dialog box, I will select the Load button. The sequence will now download to my controller. To verify and activate my program, from the Monitoring tab, I will scroll down to my program. I will then right-click my program, select Activate, Selected Items. Select Yes, and the program will turn green when it is active. Now I will double-click and open my program. In my invoke transition, you will see a flag block called C, and it's in the flags control module. When it is turned on, the sequence will begin. Here is the flags control module that I built prior to the course. You will see here there is a block called C. When that block becomes true, the sequence will begin. I will open up the flags control module from monitoring. Monitoring is what's running in the controller. I will now turn on the C flag and it will run my sequence. I have slowed down the sequence so you can see it executing. The whole sequence actually executed in less than a second. When the whole sequence is completed, you will see it noted at the top of the chart. Now I will scroll through the entire sequence so you can see the colors. The invoke is still true. The first step is completed. This transition is true. And step 2 is completed. To reset the sequence to idle, I will turn off the invoke flag. Next, I will select the sequence chart and double-click on the white space. I will select the Status tab. Here is a state diagram. This explains how to get to a desired state. We are currently in the complete state. To get to idle, we must select the Reset button. I will demonstrate. From the completed state, I will select the Reset button. It will now take me to the idle state. If you would like to test your sequence and not have to turn on the invoke, you can bypass the invoke by pressing the Start button. I will demonstrate. The sequence ran in the background. To get back to idle, I will select the Reset button. This is how you test your sequence in Control Builder, but I will now show you how to test it in Station. I will open up Station. I will set Station to Manager to avoid any operator permissions. Now I will detail my SCM by entering in the name of the SCM in the command line and hitting F12. This is the detailed display of my pressure SCM. The commands I used in Control Builder are located here. Here is the state diagram if the operator needs to use the state diagram to decide which button to press. In Station, you can also view the chart from Control Builder. To test my sequence in Station, from the command menu, I will select the Start button. The sequence executed. It is now showing complete. The command window can also be used to reset it back to idle and also inactivate. From Station, you can also scroll through your SCM. You can also attach the invoke to an operator button on a display. I will show you. Here's an operator display, and in the lower right-hand corner you can see I have a button that's attached to the SCM. Experion logs an event for every operator action. I will go to the event table to show you. Select View, Events, Event Summary. You will see here some of the SCM events. You will also see here the message I sent to the operator from the message block. I can also add this message to a display. This is what I will cover for this first lesson on building SCMs. I will now show you some troubleshooting on SCMs. I will now run this SCM and show you what an outer range warning looks like. I will open up the flags control module and activate the SCM from the C flag. PC16's output has a range of 0 to 100. But you can see here I set an expression to move it to 120, which is over PC16's limit. The SCM will turn this expression yellow when you have exceeded the range of the control module. In this example, I've set an error into one of my expressions. I will open up the flags control module. I will run the SCM by turning on the flag. Control Builder will turn the expression red that the error has occurred. In step 13, Control Builder is telling you that it cannot change the output of PC16. The real error has occurred in step 12 where I set it to the wrong mode. An understanding of how the logic works is necessary. To correct this issue, I will first turn off the flag. To declutter the screen, I will close out the control module for the flags. I will then go to the properties of the SCM by double-clicking. I will navigate to the Status tab. Here is the handy state diagram. I'm currently in the running state. I must get to the aborted state. To do this, I will press the Abort button. I am now in the aborted state. To get to the idle state, I will press the Reset button. I am now in the idle state. To go inactive, I will press the Inactive button. The SCM is now inactive. I can now close everything out and make the necessary changes. I will open up the SCM from the project side. I will navigate to the expression that has the error, and I will make the change. I can highlight the point parameter and select Fetch Enums. I can see the necessary enumeration is 0 for manual. I will now make the correction, select OK, save my SCM, close out the chart, and re-download the SCM. Select Load. My SCM is now downloaded. From the monitoring side, I can right-click and activate my SCM. Now the SCM is active, and I will open it up. I will open up my flag CM, and I will invoke the C flag to turn on my SCM. The SCM has now completed successfully. In my next video, I will expand on this SCM with more techniques.
I think we have done for the day. Okay, I am sharing like a feedback form and assessment form in the chat window. Is there any doubts? Okay, yesterday I think somebody was asking like Ethernet and what is the difference between Ethernet and FTE. Okay, so FTE is like a Honeywell proprietary product. It's patent one, but FTE, the Ethernet is like open protocol. So it's like when we are working in the server. Okay, okay. So Honeywell, if you use the FTE protocol, so we will be installing like a FTE Mux software here. When we have a two physical network, so it will be installed on virtual network, and here it will be configured as a only one IP. So, but in case of Ethernet, if we have a two Ethernet port, we will be assigning two different Ethernet, and this will not work as a redundant format. So this will be try to communicate with a different IP. This will be try to communicate with a different IP. So it doesn't know that one is for a primary, another is for secondary. So both will be having different communication. But whereas in FTE network, so if even though if you have a two physical network, so this will be considered as a only one IP. When one physical network is failed, so automatically it will switch over to the another physical network. So it will help to like a redundancy by using one IP. So that's one of the difference, major difference between like Ethernet and FTE. And there are somebody was asking about like a cold junction. Just a second, let me open that. Okay, cold junction compensation. When I checked with the expert, they are telling like during a driver configuration, you will be having like a methods of a device. There is a various methods will be uh, uh, processed during configuring the devices. So it's like a batch continuously. It will be asking like a what type of transducer and what is the like a K or J type, what type of it is, and during the process, it will be prompt like a whether you are going to do cold junction compensation or not. So if we enable that cold junction compensation, then automatically you can use as a normal input. That's what I heard from the expert. But if you want still more details, just you can send me the query. Maybe I can. I will write my email ID. Okay, I'm writing my email ID. Please reach out to me, or there are some SI assist team. Okay, which will be supporting for a system integrator. Okay, you can reach out to them like a SI assist also. Let me share that email address. Okay. So we have a system integrator assist team. You can reach out to them, or you can send a mail to me. So if possible, I will try to get answers for you. Okay. So can you please navigate to control builder? There is no option like that. No, okay. Can you please, instead of chatting, if you are able to come, like you are able to talk, please, can you tell me what exactly you need? Or please reach out to me in email address. Okay, is there any utterance certificate? Yes, but everything will be linked with this digital university, which I okay already pasted. I am pasting once again. Okay, so we have to do enrollment here. Okay, so I will provide a certificate and whatever it may be. Okay. certificate, and I will check the attendance percentage also. Okay, I am sharing. Just a second. Let me share. Just please wait. Okay, feedback form, and sorry, I pasted a long. So I have entered a feedback form. Okay, I'm entering assessment form also. Okay, so I'm requesting everyone to please provide a feedback and like a complete your assessment. Okay, and thanks everyone. Please can reach out to me if there is any
Sir,
doubt.
sir, please, I'm asking about the completion certificate. How can we get it?
No, that's what like a completion certificate will be available in this digital university. So you have to do enrollment. Once you done your enrollment, okay, so there I will see your attendance is marked or not. So your attendance is marked 100%, then automatically certificate will be generated there.
Okay, that is the only way,
Okay.
huh?
Yeah, correct.
Okay.
Because
So what about the
certificate? No, certificate I am which is not I am generating. So the digital university only automatically will be generating the address when your attendance is above 80%.
Okay, good. So what about the records of yesterday and today?
Recording I will be sharing.
How?
But again, this will be shared in the digital university only. But may I know? I think I'm getting some noise. Okay, may I know what is the problem in registering in this? Do you have any problem in registering digital university?
For me, it's okay. I'm registered and enrolled the training, but I don't
Okay.
know how to get the records. Yesterday and
No,
today records.
yeah, recording I will be uploading this same course only. From there you can download it or you can view at
From
any
where,
time.
sorry?
The same where you enrolled the course, right?
Yes.
Okay, let me show you like a previous courses where what I did.
Yes, please.
It's loading. So in digital university where you are enrolling the course, right? In the same course, recordings will be uploaded. So from there you can. Sorry, due to noise, I have muted all. Okay. So what I'm trying to do. See, I'm pasting the one of the screenshot. So if you see there already, I have uploaded the recordings of the older control HPLC training. So from there you can download the trainings. Okay, from the digital university. Similar way, I will be uploading the recordings for this session, so you can download it from there.
Okay, thank you so much.
Okay, yeah. Thank you all.
Thank you so much. Happy
briefly.
holidays. Bye.
Thank you.
Yeah. So if you have
Let's
any,
look at,
so
let's look at the file I was telling you.
sorry,
Hmm?
sorry.
Yeah, I shared my screen with you.
Correct. Okay. Yeah. So what you did, like you.
So this is put out the file is this. So
Okay, open.
if I open like
Nothing.
this.
Okay. Now you got this right. Now you go to like a right click this disk one.
This
One
one.
second. Correct. Okay. Open with.
With zip.
No, not zip. Open somewhere. We have option for open.
Okay, let me.
Nothing. Okay. Then
No,
launch.
there is
Okay.
option. There are option. I just that I.
Okay. VMware workstation.
This one. Yeah. Okay.
Hmm.
It's
Okay.
giving
Just
default.
okay. Okay. Click OK. In virtual machine, can you click file,
Yes.
new virtual machine, new virtual machine. Okay. Next. Okay. Installer disk image file. Just browse. Click browse.
Hey, Padu, we will need to actually open the virtual machine, not create a new one.
Okay.
Okay. So I should go back.
So yeah, Richard, if you go back, go to File, click on Open. And then, yeah, select that particular file, LX patch that you see on the right side. Yeah. Open that.
I did this thing before, but it gave
Yeah, you can
the
give
name of
any name,
any
or the
name.
same name, LX patch. Okay.
Just like it.
Yeah, import. Is it correct, Sid? I think import.
Yeah.
But yeah.
Yeah, this will take about, depending on your computer, this can take about 15 to 20 minutes. It will basically import the whole image. But you can reach out to me directly on the email thread that we have. If you have any issues there, we can get on another call and go over this.
Okay. Thank you very much. Yesterday when I did it from here, he went to a point and showed error so that it cannot continue. Let me see what happens today.
Yeah, I think similar way you can do all the servers.
Yeah.
Okay, if you have any doubt, you can either reach Siddharth or you can reach out to me.
Okay.
Okay. Yeah.
Okay. Thank you very much.
Thank you.
Bye.
Thank you all. Bye.
Bye. Network. I can't make it yesterday. Can you name?